Bismillahirrahmanirrahim. Assalamu alaikum my YouTube students. Dear students, today we are going to discuss exercise 1.3 question number 2 to question number 4 of chapter 1 class 10th book ILMI. In the previous lecture we have discussed how we are going to solve questions reducible to quadratic form type 1. So here is question number 2. We are going to solve question number 2 of such type. You can see that this question is not in standard form of quadratic equation. First we have to convert this equation in standard form of quadratic equation, that is ax square plus bx plus c is equal to 0, 2x raised to the power 4 minus 9x square and plus 4 is equal to 0. We know that whenever we are having variable with double power like x square, so these both two powers will be multiplied, so it becomes 2 2s are 4. If it is x cube square, then it will be x 3 2s are x raised to the power 6. Whenever we are having a variable with double power, then these both two powers will be multiplied with each other. So we can write it down as 2x square, then it will become 2 2s are 4, and 9x square plus 4 is equal to 0. Now let's replace x square as y. So this equation becomes 2. If we are going to replace as y and this also as y, so this equation becomes 2y square minus 9y plus 4 is equal to 0. And now here you can see that this equation where we are having x raised to the power 4 is reducible to quadratic form. 2y square minus 9y plus 4 is equal to 0, and this is in standard form of quadratic equation. So we can apply quadratic formula to solve this equation. We can do factorization by middle term break, so you can adopt any method. Here I am going to solve this equation by middle term break. You know that middle term break we have to multiply the coefficient first and last. 4 2s are 8, and after multiplication we must be having 8, and after adding these both two numbers we would be having minus 9. So these two numbers are minus 8 multiplied by minus 1, minus 8 minus 1s are 8, and minus 8 minus 1, if we are going to add them, it will be minus 9. So 2y square minus 8y minus y plus 4 is equal to 0. Now we can take common at 2y, y minus 4 minus 1, y minus 4 is equal to 0. When we are taking negative as common, so this negative is common from y, and this positive will be converted into negative. Now let's take y minus 4 common, and here I am having 2y minus 1 is equal to 0. Now we have to apply either and or condition. Either two y minus 1 is equal to 0, or y minus 4 is equal to 0. If I am having 2y minus 1 is equal to 0, then here 2y is equal to 1 and y is equal to 1 upon 2. And if y minus 4 is equal to 0, then y is equal to 4. Now we are having y is equal to 1 upon 2 and y is equal to 4. Now we are going to resubstituting the value of y, that is x square is equal to 1 upon 2 and x square is equal to 4. Taking square root on both sides to cancel this square. So here we are having 1 upon 2. This square is cancelled with this square root. So we are having x is equal to plus minus 1 upon under root 2. Or x is equal to plus minus 2. And the solution set will be these 4 plus minus 2 and plus minus 1 upon under root 2. As the equation is having x raised to the power 4, then it must be having 4 solutions: plus 2, minus 2, plus 1 upon 2 and minus 1 upon 2. I hope you have understood this question. Now let's do question number 3 of exercise 1.3. Now let's solve question number 3. 5x raised to the power 1 upon 2 is equal to 7x raised to the power 1 upon 4 minus 2. First of all, let's convert it into a standard form of quadratic equation. Power 1 upon 2 minus 7x raised to the power 1 upon 4, and when this minus 2 will go on the other side of equation, it becomes plus 2 is equal to 0. After converting this into a standard form, we have to reduce it into quadratic form. So let's take this x raised to the power 1 upon 4 as y. So let x raised to the power 1 upon 4 is equal to y. Taking square on both sides, 2 2s are 4. So x raised to the power 1 upon 2 is equal to y square. Now we are having, now let's substitute this in equation 1. Let's give it as a in equation 1. So this equation 1 becomes 5. So 5y square minus 7 x raised to the power 1 upon 4 is equal to y. So 7y plus 2 is equal to 0. We have reduced this equation in standard quadratic form. Now we can apply factorization by middle term break as well as by quadratic formula. We can solve this. But here I am using factorization by middle term break. Now I have to find 2 digits to whom I multiply and get 10. 5 2s are 10, 5 2s are 10, and after addition of the same digits I must be having minus 7. So these 2 digits are 5, minus 5 and minus 2. Minus 5 and minus 2 will give me 10 after multiplication, and after addition it will give me minus 7. So 5y square minus 5y minus 2y plus 2 is equal to 0. Let's take 5y as common. It will be y minus 1 minus 2y minus 1 is equal to 0. Now from this equation you can have y minus 1 as common, 5y minus 2. Afterwards apply either and or condition. Either y minus 1 is equal to 0 or 5y minus 2 is equal to 0. From here you can have y is equal to 1 and here y is equal to 2 upon 5. These both two are the solution of this equation. But I have to find solution of this equation. So now let's resubstitute the value of y. I am having y is equal to 1 and y is equal to 2 upon 5. What was the value of y? Yes, y was having value x raised to the power 1 upon 4. Let's resubstitute its value. Taking fourth power on both sides of equation. So this 4 will be cancelled with this. So here 1 raised to the power 4, 1 raised to the power 4 is equal to 1, and here we are having this 4 will be cancelled with 4. So x is equal to 2 raised to the power 4 upon 5 raised to the power 4. 2 raised to the power 4 is 16 and 5 raised to the power 4 is equal to 625. Now this and these both two are solution of this equation. So solution set will be 1 and 16 upon 625. I hope you have understood this question. So now let's do question number 4. In this one question as well, we have to convert first it into standard form. That will be x raised to the power 2 upon 3 minus 15 x raised to the power 1 upon 3 plus 54 is equal to 0. After converting this equation in standard form, we have to reduce it into quadratic form. So let x raised to the power 1 upon 3 as y, taking square on both sides, 1 upon 3 whole square is equal to y square. So it becomes x raised to the power 2 upon 3 is equal to y square. Now substitute x raised to the power 1 upon 3 is equal to y and x raised to the power 2 upon 3 as y square in this equation. So this equation becomes y square minus 15y plus 54 is equal to 0. Now after multiplying, I need two digits to whom we multiply and will get 54, and same digit after adding these same digit will get minus 15. So these two digits are minus 9 and minus 6. 9 6 are positive 54 and minus 9 minus 6 will be minus 15. So y square minus 9y minus 6y plus 54 is equal to 0. So let's take y as common, y minus 9 minus 6 as common, y minus 6 9s are 54 is equal to 0. Now y minus 9 is taken as common and the remaining will be y minus 6. Now apply either and or condition. Either y minus 9 is equal to 0 or y minus 6 is equal to 0. So here we got y is equal to 9 and y is equal to 6. These both two are solutions of this equation, but we need solution of this equation. So let's resubstitute value of y, that is x raised to the power 1 upon 3, that is equal to 6. Taking cube on both sides to cancel this 3. So it will be, this 3 will be cancelled with 3, x is equal to 9 cube will be 729. Here again we have to take this cube to cancel this 3, 1 cancelled, and 6 cube. So it will be 6 cube is equal to 216. So we have got two solution sets, 729 and 216. These both two are solution set of this equation. I hope you have understood question number 2 to question number 4. In my next video, we are going to solve further questions of exercise 1.3. So keep watching and keep smiling. Allah Hafiz.